Thank you, Chris, and welcome all to this TRIB session of the Digital Twin Summit today. We have an interesting agenda today. We'll start with giving you a brief introduction around the TRIB, or the Transport Research Innovation Board. That will then be followed by an overview of the Transport Digital Twin vision and roadmap that was developed over the last year. We will then hear from a few select SMEs on digital twin use cases, and we'll have then the opportunity at the end for some Q&A. So moving on to the TRIB overview. The TRIB is made up of government and industry, academic stakeholders representing the various transport modes. And its purpose really is sixfold. It's focused on joining up leaders, identifying priority areas, areas with most promise, areas where we really should set focus for innovation. It's focused on joining up activities, coordinating activities better to meet shared strategic needs across the members and the wider community, improving value from existing and planned work. It's focused on leveraging funding, enable the funding of larger scale projects, more ambitious projects. It's also crucially focused on facilitating demonstrators, accelerating ideas, and testing them in practice to bring them to market sooner than we would do otherwise. There's a global engagement angle to the TRIB, seizing really an advantage in the rapidly evolving and economically strategic transport technology sector. And then finally, to create a line of sight to government priorities, understand the priorities of the Secretaries of State of the Department for Transport. And across these organizations, it's interesting to note that there is quite a sizable R&D budget, annual R&D budget of £1.2 billion, apologies, not including the DFT or the former BAYS. So that's quite a sizable representation there. And the TRIB consists of a number of entities. It consists, first of all, of the board that provides a strategic steer and direction, collective voice responses to opportunities, consultations, and ensures that programs focus on the right priorities across the TRIB members. It is supported by two working groups. On the one hand side, the Infrastructure Working Group and the Transport Systems Working Group, which I chair. And these provide expert steer on the individual topics, the projects, and activities that are agreed by the TRIB board. The working groups themselves are supported by a strategic advisory network to actively engage with the supply chain and the end users to ensure that innovation really satisfies their needs and to enhance the impact of TRIB on the wider transport research and innovation community. Over the last year, one of the key priority areas for the TRIB has been digital twins, which, on the development of the digital twin vision and roadmap for transport, was our flagship project that was delivered by the Connected Places Catapult in collaboration with TRIB members. And my colleague Yalena shortly will be providing an overview of this project that represents a significant milestone on our journey towards supporting TRIB members, but also government, wider industry, and academia to work effectively and efficiently on the future development of digital twins. So without further ado, I'd like to hand over to Yalena now, who will give you an overview of the Transport Digital Twin vision and roadmap. Thank you.
Great. Thank you so much, Wolfgang, for the introduction, and hi, and welcome, everybody. So I am Yalena Coleman. I am the Director for Applied Data and Technology here at CPC, and I've been leading on the development of the vision and roadmap on behalf of CPC as commissioned by the TRIB members. So I really want to explain a little bit more around why we have done this important work So the TRIB members have identified that there is a need for research and development funding to enable the UK to develop digital twin capability for transport. So connected or federated digital twins really have the potential to revolutionize real-time monitoring of systems. So through simulation and optimization and accurate forecasting, we can really play a key role in transitioning to net zero. Other things like improving the user experience, increasing resilience of our systems, improving safety, and accelerating innovation. So using connected digital twins as a tool for us to get improved knowledge of the transport infrastructure system and its operational status will allow it to be better modeled, understood, and simulated. So having this deeper understanding can create both financial and time efficiencies in the identification, design, and implementation of new products. So one of the key benefits of this roadmap is to really understand how digital twins can enable organizations and parties jointly to move towards the desired impact, specifically on decarbonization, with the resulting insights from digital twins in the transport industry being used to inform longer-term strategic decisions on zero carbon solutions. So the TRIB members are really using this as an opportunity to put the UK at the forefront of digital twinning capability in the transport sector by developing a unified vision and roadmap for 2035. So by taking a coordinated approach to this, the shared vision and roadmap can help to steer industry, academia, government, and the research and innovation community in a unified direction and provide a view of the steps that we need to undertake to achieve the vision. So this work is intended to set a solid foundation and also to outline a path for what TRIB members and other broader stakeholders need to do. It will also feed into the development of the UKRI Digital Twin Research Programme. So in order to understand the landscape of existing and emerging digital twins, we conducted a literature review of over 60 publications. This included things from academia, research. It included market analysis, such as the UK's competitiveness in digital twins. And it was covered both digital twin related and transport related documents and case studies. So what this helped us to do was identify some of the blockers, but also some of the enablers, which can accelerate the implementation and adoption of digital twins in transport. It identified both existing standards and some of the key components that these apply to, and also guiding principles such as the Gemini principles, which you would have heard about in Alison's keynote earlier. So essentially, involvement and collaboration from a very broad range of stakeholders has really been critical to the development of this roadmap. And you can see here that over 80 different organizations have been engaged during the development. And they have been interviewed or engaged on small groups to really understand and explore how they are using digital twins currently and what their plans are for digital twins in the future. So these were transport sector stakeholders, as well as adjacent sectors such as energy, telecommunications, and the built environment. So we consulted experts from industry, both large businesses and SMEs, academia, public sector, as well as representatives from the research and innovation community. We've also supplemented this research with engagement on the Digital Twin Hub. So moving on now to what the vision actually is. After much review and revision, this is the vision that we've settled on. Our vision is to enable a trusted ecosystem of connected digital twins for multimodal UK transport networks. This will facilitate effective decision-making to optimize solutions and deliver efficient, safe, and environmentally conscious mobility for people and goods. It's quite difficult to sum up a vision in 2 sentences, but this is where we've landed, and we hope that the content within the roadmap itself will provide more substance to that vision. So essentially, we see the roadmap as being an essential tool for engagement and alignment around the common strategic priorities that we've mentioned earlier. This will also provide an outline of the activities and the building blocks to deliver the vision. It will enable improved facilitation, coordination across the TRIB members, broader stakeholders and investors in digital twin research. Crucially, we really want this to enable the social, environmental and technical change that is going to be required to achieve the shared vision. So going now into a quick snapshot of what the roadmap looks like. It has been released this morning. You can see the URL at the end of the presentation. We will share this. It essentially is made up of 4 different work streams. These are strategy and innovation, the enabling environment needed for digital twins, people, skills and culture, and then last but not least, the technology and data that underpins digital twins. So each of these 4 work streams has a number of components, and we also have an expected target output end year, by which time we would expect the outputs to be completed for the various areas and components. Drilling down into more detail on each of these, we have outcomes, outputs, and activities associated with each of the elements on the roadmap. And here you can see some of the key contributors. And this is our key 4 stakeholder groups: academia, industry, government, and innovation funding bodies. We've also given an indication of which of these stakeholders we would expect to lead on these activities and who would provide support and contribution into these. So as part of the roadmap development process, we have had a number of SMEs who've developed use cases to illustrate and really bring this to life. We will hear from some of them shortly. And the other thing which we've done is to look at different scenarios for 2035. So we posited 4 different types of scenarios, thinking about what our world might be in the short term, and really bringing to life how transport digital twins can help us to achieve the vision that we all want to see. So finally, I want to say a very, very big thank you to all the partners that contributed to this. There are many hours spent in discussion and review. This wouldn't have been possible without all of you. So what's next? Here is the link to access the vision and roadmap online. And we would like you to contact us if you'd like to participate in making this vision a reality. So we don't intend for this to be something which is produced and merely sits on a shelf. We are seeing this as a high-level strategic view of the activities that need to be done. What we would like is to work with all of you to operationalize this and start on the journey of implementing the roadmap. So please do use this email address to contact the TRIB group. We would like to work with all of you, whether you fall into one of those categories or are a different type of stakeholder. We'd love to hear from you. Thank you very much. Right, next we are going to hear further on some of the use cases. So I'd like to welcome Nicholas from Open Space. Thank you very much. Before we go into the SME presentations, if you're thinking about questions that occur to you, please do use Slido. So you have a QR code on the bottom of your badge. We won't be taking questions directly from the audience so that everyone can see the questions and upvote them. Please do enter your questions onto Slido in stream 2. So it needs to be specifically in that stream for it to come up on this group's set of questions. We will be going through all the SME presentations and then having a Q&A at the end. Thank you. Over to you, Nicholas.
Thank you very much. Good morning, everybody. It's a real pleasure to be here with you, sharing really the outcome of 4 years of work, started with the support of Catapult, actually, in Milton Keynes. So it's a real pleasure now to feel part of a growing communities of people interested in digital twin. So, Open Space is a UK startup building digital replica of railway stations to improve customer experience, reduce cost, and increase revenue. Ultimately, we want buildings and cities to be designed and operated with a real sense and understanding of the movement of people and their behaviors. So today I'm here to speak about two things really. How we use the concept of digital twin at St. Pancras stations in collaboration with HS1, and how we are starting to think to scale our digital twin infrastructure with HS1, starting linking a number of twins together. So Open Space, we are expert in people movement, insight, and simulations. And this is what we do for the last 20 years, but on a consultancy basis. So for the last 5 years, we are transforming, if you like, our business to be a product-based business so that we can build solutions that help our clients, operators, or designers build digital twin for managing people flow. The use case for digital twin for us is pretty straightforward. I think there is a clear lack of data around people movement and behaviors in buildings. Okay? And the question is really obvious, is how can you manage and improve something if you don't have any measurements? Okay? And the digital twin allows us to, first of all, collect data, fuse data, but it's also an environment where we can build, ultimately, our key domain expertise is pedestrian simulation technology. So now data and simulation allows us to imagine alternative ways of operating your asset. We can deploy this strategy in the physical building. Because we are measuring the physical building in real time continuously, we ultimately have an optimization machinery that allows us to fail fast, i.e. to become better quicker. Interestingly, I would say, up to 12 months ago, nobody really could answer any of these questions at St. Pancras. And it is not only St. Pancras, we're doing similar things at Houston stations, and we encounter the same issues and challenges. How many people are in the station now? Is it overcrowded? What the comfort? What's the experience of people? There is a serious lack of data to be able to capture that and help operators make better decisions. So in 2020 and 2021, we started to building a first operational digital twin to manage the movement of people at St. Pancras stations. We first embarked on scanning the stations. We use that digital replica to plan a monitoring infrastructure that has been installed in 2021. And now we are starting the third phase, which is providing data and unlocking insight, working on automations that the data that we have allows us to consider. It's all about data. It's data about people only. Yeah? So we look at the problem from a people-centric perspective, and we take third-party APIs from a range of service providers at Houston in order to fundamentally monitor and KPIs, if you like, the day-to-day operation of the stations. Here you've got simulation technology that has been informed with data that we collect from the site. So not only you have data, but you also have better simulation model that now can be kind of data-driven, if you like. Okay. And there are another sets of tools that, because our platform is based on gaming technologies, we can play with VRs and ARs and a number of features that allows us to bring the customers and the operators a little bit closer to how it feels to walk in that building. So for the future, as I said, we are working on a commercial basis with HS1 for the last 2 years now. And the vision really is once we've secured, if you like, this minimum viable digital twin infrastructure at St. Pancras, Epfleet, and Stratford, then the challenge is starting linking them together. Okay. And this is what we are currently doing at St. Pancras. I didn't expect to click. So then how do we link this existing digital twin together? We bring additional data, so the train service patterns, for example. We bring static data like surveys or matrices, and we feed that into our algorithms that allows us to go from count to movement. And I think these are the key things that we are able to do, and I think is unique at this stage. Okay. Once we've got this additional data, what we can do is near real-time feed data set, footfall at those various stations, St. Pancras, Epfleet, and Stratford, in order then to be able to do this. We believe this is one of the first pedestrian simulation that is ultimately kind of a multi-agent. And what you see here, at scale I mean by that, what you see here wasn't the movement of trains. These were people moving on the railways. And I think this is one of the limitations we've observed in the rail industry. There is still a tendency to want to move trains and not people. The lack of data, the lack of tool is obviously, will obviously help them trying to kind of improve that particular perspective of their business. But you can see with this video how by adding that kind of central piece on the network, we can now start navigating from one twin to another one. Okay. Just to conclude, two slides. I think what we've observed over the last year is the impact of data about movement of people. Okay? First of all, everybody relates to it. Then, very quickly, everybody's happy to sit around the same tables because they see the value. And what you unlock is collaborations. It's often the case that before we start a project, we are basically, the main challenge is to manage our stakeholders that want to be part of the project. So data and digital twin does work in terms of enabling collaborations. Ultimately, 1, 2, 3, this is what we specialize in. I've just said the key output and benefit is data-driven collaborations. And to conclude, really, interestingly also, what we've observed is benefit around, I would say, 3 facets of the industry, which ultimately start by the customer experience, because they have better data that is more accurate and timely data. It also helps the operators to configure their assets so that it serves the movement of people. It's better aligned to the movement of people depending on which day of the week, morning, evening. What do I mean by that is when escalators can be switched off to save energy, we can do that and we can evidence the impact or the mitigation that needs to be put in place if that's what the solution is. Finally, also, I think there is a clear shift in the customer profile of railway stations in the pandemic. I think we believe there is opportunities to increase revenue by tapping into that new customer profile. So again, data is helpful there. And ultimately, I think what we found is there is no organization in our mind that is accountable for the customer first in the railways, yes? And we believe that by opening up this type of digital twin infrastructure to policymakers, it also allows them to monitor the impact of their policies over the long term. Thank you very much for the opportunity to share this use case, and I very much look forward to hear more about other applications of digital twin. Thank you.
Thank you very much for that, Nicholas. Next up, I would like to welcome Robert from Slingshot Simulations.
Thank you, Yalena. Good morning, everybody. I don't know about how you're all feeling, but I think we could do with a digital twin of the temperature in this room. I am roasting. I don't know about you guys. So, my name's Rob Harwood. I'm here to talk to you a little bit about the use case that Slingshot Simulations undertook. And let me firstly express my thanks to the TRIB, to the Connected Places Catapult, and to the broader ecosystem that supported this entire project. For an SME, this type of funding, this type of visibility, the ability to connect is absolutely critical. So it plays a critical role in driving innovation and connecting innovation and delivering innovation to market. We are a place-based decision intelligence company, and we have a very specific focus on net zero and climate resilience solutions. We know, and we're all sat in this room when we're talking about decarbonisation, we're talking about climate resilience, that speed is of the essence. Speed is of the imperative. But it's not just speed to the transition, it's how do we make a just transition? How do we use data and how do we use models and simulations to inform a just transition, not just a transition at speed? And we cannot afford slew movers, fake movers, or any form of greenwashing. We have to act, and we have to act quickly. But rapid decision-making in a place-based context is very difficult. It's incredibly challenging to do that. And I found this quote that supported that from a management consultant. We can get into a realm of analysis paralysis. And actually what we see is a massive, essentially decision-making chasm, as it will, between on the one side, you have very high-level policy statements. We will be net zero by 20, pick a number. right? And it looks great, and we can put a nice pie chart together. At the other end of that spectrum, you have detailed design of a specific intervention, which is very expensive, it takes a long time, it's very necessary, but it's not going to give us the speed that we need. How do we rapidly sift millions of options of interventions that we could do? How do we leverage digital twins? How do we leverage data to do that? And how do we navigate through that when we've got so much innovation in technology, we've got so many policy options, we live in very uncertain times from a financial perspective, right? How do we navigate through all those constraints at speed and enable the people that have to make the decisions, give them the insight to make the right decision at speed? We're here because we're talking about digital twins, and I think we know that digital twins are a vehicle and an opportunity for us to deliver that. And I love the theme of the connected digital twins because we can't operate in silos. We have to think holistically to deliver this just transition. So we've got some frameworks, we've got some methodologies, we've got some principles of how to get there, and it's great to see this community coming together. But we see when we talk to people in market, there are many challenges, but there are 3 that we can help with, and there are 3 that we talk about a lot. It was interesting talking about the people in the previous presentation that there's no data. The people we talk to are overwhelmed by data. There's actually a data deluge, but it's everywhere. It's disconnected, it's siloed, it's on Joe's laptop, or it's in a spreadsheet somewhere that nobody can use. It's in a satellite image, it's coming from a streaming sensor. How do you connect all that data together to make sense of it at speed? A lot of the analytics and modeling that we do is highly siloed. We have a transport team who are looking very much from a transport perspective. Can I move from A to B, and what's my congestion and travel time? We have a flooding team who are doing some hydrological modeling and saying, well, this might happen in the future. We have an air quality team. They all need to interact and connect, but our analytics today is siloed. And that's all compounded by a skills and resource gap. I think we all acknowledge its hiring is difficult in data science and digital skills, so it's good to see the training program as part of the overall program. So how do we address those problems? Because they're introducing a lot of inertia and slowing the decision-making process that we need to make. So that's what we're developing technology to address. And that's what part of our TRIB project was, how to demonstrate, A, can you develop a platform, can you deliver a place-based solution that is pre-populated with a lot of the credible, reliable, trusted, open data that's out there, that the government is putting out there. It's all there. How can we bring that together? It's already surfaced for you. Specify your region. The data's there at your fingertips. How do we link modeling and simulation together? Our core IP, our core underlying technology enables you to bring different simulation capabilities together without having to be a modeling and simulation domain expert. Is it going to be as accurate as what they could produce? No, but we don't need that when we're looking for directionality and rapid sifting. We just need to know what our shortlist is for the business case. How do we get to that shortlist at speed? Okay, that's what this enables you to do. Once you've got those 2 capabilities, that enables you to not look at 10 scenarios, enables you to look at 1 million scenarios, hundreds of thousands of scenarios at speed in the cloud using AI, using digital twins. That's what it enables. So we can make better decisions faster, more holistically, and at lower cost. Our specific project, the demonstrator that we showed, we picked Bristol, and we just showed as a geospatial area of Bristol, how can we optioneer around low emission zones? And if we just draw, and you can go in the tool and just sketch a low emission zone and say, what happens to the traffic? Which is great, you solve the problem within that low emission zone. That's pretty self-explanatory. But then you start moving vehicles, because we're going to be living with petrol engine cars, like it or not, for a good number of years to come. Where do they go? They've still got to get from A to B, and they're still going to move. Well, how do you correlate that with things like EPC ratings, which is typically not done? So if you start moving vehicles, and this is just a simple example, if you start moving vehicles that are giving out now emissions, low EPC ratings means you've got single pane windows and you've got quite porous buildings. So the people that live there are going to be adversely affected by noise, and they're going to be adversely affected by air quality and pollution. So by bringing the data, bringing the simulations together in a common environment, you're not having to talk to 5 different teams to try and get an answer. You can get your impact and you can get your answer right there. And then you can start to visualize, you can start to leverage an indirect benefit of the digital twin, which is that power to engage decision makers early with compelling, visual. It's not a static PDF that will sit on a shelf and it's out of date by the time it's published. This is a living, dynamic solution that we can use. One of the challenges we repeatedly see in the whole digital twin community, because it's such an emergent technology, is how do you prove value? What is the quantified impact of that? We talk a lot about the technological value. We don't often get to the business value when you're going to talk to the CFO about investing in this type of thing. So we actually did, as part of the study, we worked with some of the stakeholders to try and at least estimate what we feel the impact quantitatively of that would be. Small team, 5 people, doing this type of work, typically spending 40% of their time wrangling with data, going and talking to other teams to try and bring models and simulations together. You can take a lot of that off the table. You can save up to 50 to 100K per year just in people time, internal productivity gains are not insignificant. And the time savings are immense if you can do that. If you're developing strategy, a lot of what local authorities and place-based folks are doing is they're contracting out big projects that take several years potentially, certainly in the months time frame. And they cost hundreds of thousands of pounds to get these strategic plans put together. You can accelerate that substantially and save a lot of money. And of course, if you think about the through-life cost of an intervention, if you don't get that right, or you're having to wind some of that back, that's millions of pounds. And it's years and months delaying the speed that we need to operate at. So there are 3 levels of value created here. The immediate near-term stuff and then the life cycle, all the way to the scale of the life cycle value. Digital twins have a massive impact and a massive role to play in that. And that's where we're really focused on doing that. So here are some snapshots from the project that we actually put together as part of the TRIB. And then just a little bit about Slingshot. We span out of the university in 2019, University of Leeds in 2019. We've secured substantive investment from venture capital back to invest in our core secret sauce under the hood. And what things like the Connected Places Catapult and the TRIB enable us to do is to surface that in specific use cases that add substantial value. We do work internationally with the Digital Twin Consortium, and we're a groundbreaker member. And we also like to think that we play nice in the sandbox with other digital tools. We're not trying to wrap up in a single ecosystem. Just if you're in our ecosystem, we don't like you. You're with us or against us. We like to play in the sandbox nicely. We take a standards-based approach, and we recognize that digital transformation is a team sport, and we're in it to play with the team. So anybody wants to talk about how we can integrate your models, integrate your data, we have a core, unique IP around the platform, bringing all that together. We're happy to engage and talk about how we might do that. So thank you for your time.
Great, thank you so much. Next up, we have Oytun from Evotrack. Over to you. Please don't forget to put your questions in the Slido stream too.
Right. Well, like the other 2 speakers, I want to resonate how important it is to get this kind of support. This kind of support to SMEs to enable this kind of project. So you'll see what we were able to achieve thanks to the support we have been receiving. And just to say, we spinned out from Imperial College 2 years ago, and this kind of support was crucial to actually get the motivation and the financial security to drive the projects like this. So we are a software technology company focused on public EV charging stations specifically. So we provide solutions to design them better and operate them better, which will be clear in a few seconds what we do. So I just want to set the scene why we work on this space. As many of you are aware, we're just deploying so many chargers, either home chargers or private chargers or commercial chargers, but there are so many chargers to support the electric vehicle transition. And that will be in the order of millions. We'll deploy this in Europe, in other parts of the world. And they will end up somewhere, but the question is where they will end up and whether that will be the right place and at the right time. That is an important thing because these things are quite expensive to develop. They are material intensive as well. So if you want to achieve the true climate benefits of such transition, you should not just put chargers everywhere, but you should be kind of clever how you position them and how you operate them. You could invest more, you could have 5 million, 10 million chargers, but that also means that you have to pay operation and maintenance of these chargers. When a new technology comes in, you'll have to also replace them a lot in numbers as well. So what we do as a company is we try to create this new type of information in terms of forecasts of charging demands, both short-term and long-term. to be able to make sure we build this kind of infrastructure the right in the first time. So to do that, we help charge point operators and EV fleets to provide them informed decision capability. So we generate forecasts for them, and they can use this forecast to deploy and manage the infrastructure better, or their fleet charging management better. And as I said, we're a product-oriented company, so we create the technology to do that. So if we have the data, either from the client or from public space, then we would be able to do that for you because the technology will be the same. What is that achieving in terms of real value is, let's say you operate a shop yourself, or you're a city planner and you want to put these chargers in the right places so people actually go there and use them. That will save money to people because even as a taxpayer, you're supporting this infrastructure. And if people are using it more, it means the return on this kind of investment will be much faster. And the network ecosystem can then kind of support more charging points at the right spots faster. Let's say if you're a driver and you're coming here today and you want to see if the stations around this building will be available around this time or in 2 hours' time. That kind of information doesn't exist. So we do such forecasts. So you would know what is the likelihood for you to charge your car around this building during this event, for instance. And finally, perhaps more important for future is what happens if there are external events or, for instance, extreme events as a result for climate change, for instance, and the charging supply is impacted. You have flooding in some regions, stations are disabled, or maybe you have a football match that people are coming in. How the charging supply and demand will change so drastically so the authorities can kind of actually prepare for that ahead of time. So these are the kind of questions we're trying to answer with forecasts. As I said, we have 2 types of forecasts, and I will show them, and they form the basis for the digital twin that we have. One is the long-term forecasts, which is useful if you want to know how the infrastructure around this building, again, has to change upcoming years. Not immediately, but in a few years' time. And that is useful, so you can find these ideal spots that will give kind of the money's worth to it. And we do a lot of modeling, but in reality, how it looks like is this. So as a planner or as a company, you would be able to see which regions of the city will receive how much demand in a year or in a few years. And that's important because a single forecast is not enough. I could tell you, for instance, in a year's time, like let's say Whitechapel area will receive more demand, so you should put more chargers. But it doesn't have to say that in 3 years' time that demand will sustain. So maybe you have to put more today, and then you don't have to put again anymore. Or let's say south of London usually receiving less kind of supply so far, but they may need a lot more supply in 5 years. Maybe next year not so much. So as a planner, you want to know how the landscape will change over years, not just a single year for a single time frame. So that's kind of what we're trying to do. And more importantly, people are different. We have different purposes. You may be just passing by London. You could be a tourist coming from Europe. You could be a local resident. You could be going for groceries and so on. So the charging purpose also determines how the forecast will change as well. So that's kind of the layers we're trying to embed in this kind of technology. If we look at the short-term side of things, that looks at hours ahead. And it's useful for drivers, as I mentioned, but also it's useful for instance, energy providers. When we have the electricity on, we have this projector here. Somebody is supplying that electricity on demand. That's the same when you hook your car to a charger. You need to provide that electricity on demand. If the providers know this, they can get the cheapest energy and ideally the most environmental friendly energy to you. And for the charging supply, if we could provide this kind of short-term forecast to them, then they can make the system a lot cheaper for everyone, not just for the company who is selling the energy to us. So what that looks as an interface, again, I mean, there's a lot of codes and data behind, but this is what you want to see, kind of simple enough. You can kind of look at the real-time availability of stations and kind of our predictions to you how that will change, either for regions or stations. You can go and access yourself and play with different data there. This is where it becomes important to talk about data availability as the other speakers. So this is from Paris. So this demo, we can do it because there's an open data license. We can grab in a few minutes, apply our technology, show you the results. We cannot do this easily in the UK yet because there is no open data license for such data. But if it was available tomorrow, then you would be able to access the same forecasts tomorrow as well, just to emphasize that kind of data availability aspect of things. So based on this, what we did is to illustrate how this kind of technology would be also useful for future technologies, not just like today's applications. And what we picked was shared autonomous vehicles. And these are things like taxis, ride-hailing services that you already use, but would ideally be autonomous in the future, and ideally would be electric or another alternative fuel form that we find more sustainable. So there's a lot of things that you could look at, but why we were interested in this is if you have an effective, efficient, shared autonomous fleet, you can actually require less chargers on the streets because they are quite efficient in how they access the grid and when they need charging. And we as humans, we have a lot of preferences in terms of where we go and when we want to charge a car, and they're not always the most, let's say, resource or cost effective. They're more personal preferences, even if you're the most environmental conscious person. But autonomous systems can do it much better, and they can save us time, money, and resources. And that's why we wanted to explore this, to show how our short-term forecasts could enable such fleets operating at a very good capacity. So there's some engineering work bringing this together and a lot of assumptions because such fleet doesn't exist. So for instance, we have to create a fleet simulator, assume there are a lot of people requesting them, and assume these then cars routing themselves to find the best customer to bring where and then charge where. But when you kind of figure that side up, then you can see pictures like this that helps the planners more than anything else. But what you see here is the real-time simulation of, I mean, a snippet from that, of course, of London's infrastructure when you have a lot of these shared autonomous vehicles going around at a maximum capacity. Then you can see where the hotspots are. Can you really like sustain this kind of fleet operation long-term? Or whether you should invest in some of the stations that you see less active, so you can kind of push some of the fleet there. So this kind of digital twin application with this kind of technology allows you to actually plan this ahead of time, even if such fleets doesn't exist. So when they come in effect, then we would be ready to say, okay, this is how we do the infrastructure. Let's just buy the fleet and operate them. With that, that's the end of my talk. Thank you very much for the invitation. And I just want to acknowledge all the support we have been receiving from different institutions, including the Department for Transport and BASE, Innovate UK, and of course, Catapult itself. Yeah, thank you very much.
Thank you so much, Nicholas, Robert, Oytun. Really great presentations from all of you, and it's really wonderful to see the real-life examples of what we mean when we're talking about digital twins in the transport sector. Thank you. I'd now like to invite all of you to take a seat up front, and we're going to go into some Q&A. Wolfgang as well. Thank you.
Try to keep it as simple as possible. Tricky to get on.
First question is great example from OpenSpace. Accepting that journeys rarely start or finish in a station, what opportunities are there to link with other digital twins, perhaps for bus movement or active transport, to inform the station twins?
I think good question. I think we are just doing, when we speak about end-to-end journey, it's very much end-to-end journey from a kind of a rail industry perspective. I think we don't really do the last mile. I think that's also an important kind of features of mobilities in the future. So there is a direct example of how we can take input from other digital twin for buses, for example, or boat taxis, whatever, and then we can feed back our own kind of understanding how the station works now, what are the predictions in terms of demand for taxis, buses across the day or across the week. So there's definitely a need for that.
Thank you. Next question is for Evotrack. How can we work towards overcoming the data fragmentation and interoperability barriers to realize a smooth EV charging rollout?
Well, that's a tough
Big
one, I
question.
suppose. Yeah, so actually most of the data already exists and is out there. It's more of certain industries and more governmental bodies facilitating the data being available. So they would have the benefits of actually having such technologies and models coming online. But they just need maybe someone to organize these things because they are doing a tough business in actually figuring things out. Maybe they don't have a lot of time to actually think about the data perspective of things. So the interoperability is more of a regulation and coordination issue, and I think we just have to just talk more about this and bring the industries together to do this.
Thank you. Next question is for you, Wolfgang. How are the TRIB members planning to work together to take forward the roadmap? And what happens when organizations are at different levels of maturity?
So in terms of how the TRIB takes us forward is, in essence, we are proposing to create a community of practice that will keep this live and obviously also ensures the interlink through the strategic advisory network and make sure that we obviously capture any feedback that comes in from through this advisory network. So we really make sure it suits the needs of the wider digital twin community. It will obviously be kept up to date and live. So this, as Yalena was mentioning early on, is not meant to be a project that gets shelved, but hopefully then helps inform, in essence, how we can work better and closer together and shape a program of activity that truly harnesses the power that each of the individuals in this room and wider community can bring towards creating benefits out of these digital twins.
Thank you very much. For Slingshot, for you, Robert. The flooding use case is interesting for climate resilience. What other climate risks are you seeing as important for future resilience?
Yeah, that's a really good question. And in the keynote presentations this morning, there's a lot of talk about heat in terms of Credo, and we actually have a collaborative project ongoing between Leeds University and Leeds Beckett University where we're actually looking at heat islands and inner city heat islands and the creation of that. So flooding is one thing, but heat, particularly after the summer last year, I think has got a little higher on the agenda. So we're doing some work where Beckett are doing a lot of the collection of data around urban green spaces and how they can be used to help people manage through heat islands, but in addition to flooding, we're looking at heat islands next.
Excellent, thank you. I'm going to go next to a question from Nick at Shift, and I'm going to open it out to any of you who would like to answer. What is the role in the digital twin space for urban test beds, so areas like the Olympic Park, that can open up access to all of their assets, both data and physical, to test new solutions? Would any of you like to take that, or you can each provide some comments?
Well, do you want to go start?
Well, I mean, it's a kind of very kind of interesting question and wide question, but you know, any environment that can help startup and SMEs like us to test and engage with a kind of a wider industry in order to develop, you know, collaboration in order to do that together. I mean, the world is a complex thing to capture. I think engineers can now see that, that horizon. We are going to be able to make a copy of the world, but not on our own. So test bed, if they can be the excuse to gather and do things together, I think there's clearly some value there.
If I can add to that, I think because it is a self-contained and controlled environment, it can also ensure that we set up an environment where the data is trusted. It's all coming through the same controlled mechanism, and therefore will really help then shape how we should basically set up this framework of collaboration across the different components of it that can then be a blueprint for wider collaboration across other sectors and other test beds as well.
Robert?
Yeah, I'd just make 2 points to that actually. One is validation is key, and building that confidence. I think what is the old adage that if you do an experiment, everybody believes the results except the person that did the experiment. If you do a simulation, nobody believes the results except the person that did the simulation, right? So the more validation we can get and confidence we can build, so test beds where you bring together that validation and proof point is super important. And I touched on it in my presentation earlier as well. The second point is that skills development. So you can use these test beds not only to prove out technology, but also to engage the next generation of people in digital skills.
Yeah, I can just resonate on the benchmarking aspect because that's actually something very relevant. We talk with our customers as well. Everybody wants to see how things are put together. And if it starts from the data side of things, data collection and verification, then that would accelerate everything. And everybody is also trusting these models as well.
Thank you. That makes a good lead into the next question, which is when you're collecting behavioral data, what are some of the ethical considerations? So if you're talking about people movement, things like that, what do you need to bear in mind?
Well, I think the first 4 letters that come to my mind is GDPR compliant. So, that's our starting point. Then we start to want to start thinking about the Gemini principle and how that ultimately, work together. But it's a purpose choice for us to be GDPR compliant, so you can't recognize ultimately people. We are extracting from the physical world simple traces, if you like, trajectories of people. So that's what we take from the physical world into our kind of digital environment. So we try to stay away from facial recognition or other means of improving our insights, if you like.
And I don't know whether this is more of a question for the DT Hub and the CPC, but there's a lot of development now in synthetic data sets. So that are derived from real world data sets, but solve that problem of the individuality of data. So looking into the generation and use of synthetic data might be something of interest.
Thank you. Next question is for Evotrack. Could your models predict demand on the grid in real time?
Well, that depends on what kind of data we work with, because for obvious concerns with the data privacy, but also data availability, we try to stick to what is publicly available, and that wouldn't operationally help these like real-time power provision optimization side of things. But that being said, it's perfectly possible. It just depends on the kind of the stakeholder that we engage with and what kind of data we receive from them.
Brilliant, thank you. We have time for one last question. So the last one I'd like to ask to each of you, how do you make sure that the users of the digital twins are always front and center when designing your technologies? Should we start with you, Nicholas?
I can. I think what we've learned very quickly is to avoid collecting data for the sake of collecting data and build data lake. I think that was something quite fashionable a few years ago. I think the industry now, or many of us realize at least, that you have to start from the value. So you have to start with, the first meeting is to sit with the client. What is the value they are trying to unlock? Saving cost, increasing revenues, improve customer experience. Be very specific, and then map out a journey in terms of digital transformations that is going to take them there. So it's a process, I think, more than an instant intervention, I would say.
I guess just a quick, follow-up on that. So when you also integrate data, you don't want every kind of data anyway. You want the best data, and too much data sometimes actually stops you from progressing and getting the right results for the purpose. So what we try to do is to, sometimes you can even go ahead and work with other partners, even if it's like financially costly to you, because that would save a lot of time, effort, and that would achieve better results than just trying to form these data sets yourself. If there's an expert, you should just use the expert instead.
Thank you. Oytun, over to you.
I mean, the comment I would add to that, having over 20 odd years of seeing digital solutions being built, some very successfully, some miserably failing, even though they may have super technologies. You cannot invent the technology in the 4 walls of your office. So we have built a foundational technology platform, and now we are going through a very deliberate and sequenced body of work with early adopter customers who are actually guiding and shaping the roadmap. So we've got the technology, they've got the know-how of how they want to apply that. We can't invent that, so it's that collaboration. And it's forums like this where we get exposed to this community. So if anybody in this room online wants to be part of our early adopter program, then we're more than happy to engage with that.
Yeah, and perhaps just to add to that, I think we've said earlier on, obviously, we shouldn't be technology-driven for the sake of technology, but rather looking at through the lens of the end consumers. I recall different technology projects a few years ago where there was some very fancy technology being developed, put in front of people, and it was ready to connect to autonomous vehicles, the interface for elderly people. And when it was initially presented to them, they said, we can't use this. What we really want is X, Y, and Z. So we went through a lengthy engagement process with the actual end consumers of this technology, and that applies whether it's digital twins or otherwise. And literally after a year, we came up then with a solution that was much simpler in some sense than what had been anticipated, but that was actually usable by the end consumers of that technology and provided actual value. So it's really focusing on the value to the end consumer. It's quite important. So it requires a lot of engagement. We focus much more upfront on the engagement with the users rather than on the technology, and then the technology follows, and the functional needs of the technology and the technical requirements will then be built upon that.